Hello, welcome back to our little corner on the web, where we hope to develop and nurture a love for math. Today, we will go over question 6 in part 3 of the 27th PMO qualifying stage. Again, thank you to the organizers for freely sharing the questions. So question 6 states or asks, consider the equation 3 times the floor of x squared is equal to x times the floor of x plus 21 times the fractional value of x squared, where x without symbol or is considered the greatest integer part of x, and the x with the curly braces is the fractional part of x, respectively. Okay. The sum of all solutions to the equation can be written in the form p over q, where p and q are relatively prime positive integers. What is the value of p plus q? Okay. So for those of you who want to try it first, this might be a good place to pause the video and try it before proceeding to look at one possible solution. Okay, so let's dive in. So we're given the definition or the relationship between x, the floor function, and the fractional part of x. So we can write that, and we will sort of take advantage of that, actually. So I'll write it on the upper right here. So x is just equal basically to the greatest integer part of it, okay, plus the fractional part of x. Okay. So using that, we can rewrite this original equation to get rid of x and just basically deal with the greatest integer function or the floor function and the fractional portion. So we can rewrite that now as 3 times the floor function of x squared is equal to replacing x with the floor function of x plus the fractional portion of x times the floor of x plus 21 times the fractional value of x squared. Okay, transposing everything to the left side, we will see that this actually looks very similar to a quadratic, okay, with the variables just being, basically being the floor function of x and the fractional value of x. Squared minus the floor times the fractional value of x minus 21 times the square of the fractional value of x. Okay, so simplifying this a bit, we have 2 times the floor function of x squared minus the product of the floor and the fractional part minus 21 times the fractional value of x squared equals 0. Okay, so just like we do with quadratics, we factor. So here we can factor it as well. 2 times the floor of x minus 7 times the fractional value of x times the floor of x plus 3 times the fractional value of x. And that product of those two binomials must be equal to 0. So that means that each part of those, this part or this part, can alternatively be 0. So let's deal with the easier part first, the first one. Okay. The first one, since we know that curly braces x is fractional, well, to get an integer value, then it has to be something over 7. Okay. Written differently, it's basically 2 times the floor of x is equals to 7 times the fractional value of x. So the only fractional values that will work, since the left-hand side is even, is 2 sevenths, 4 sevenths, and 6 sevenths. So we'll just try all of them. So case 1 basically becomes 2 times 1 is equals to 7 times 2 sevenths. This gives us 1 and 2 sevenths as a result for x. Okay. The next one will be or case 2 for this side is 2 times 2 is equals to 7 times 4/7. So this gives us as a result x is equals to 2 and 4/7. And oops, third case, okay, third case is 2 times 3 is equals to 7 times 6/7. And you can try, but there's no other fraction that will satisfy. So we have the 3 solutions for the first binomial. Okay, so now it's just the second binomial. Let's do that. And this one's a little trickier. One way to think about the relationship that's written here is in the number line. Okay, so for negative values of x, the floor of x is not just ignoring the fractional part as we did in the cases where x was positive. If x is, let's say, between 0 and -1, okay, the floor actually is the integer that's to the left of it. Okay, it's the integer to the left of it. So the floor of, for example, -1/2 is -1. Okay, so keeping that in mind, we can now sort of solve for the for this binomial that's underlined. So the floor of x is equals to -3 times the fractional value of x. So one thing that satisfies here is -1 is equals to -3 times 1/3. Okay, so that means the floor is -1. If we add the fractional part of 1/3, this is actually x equals -2/3. So there's only one case left. The floor of x equal, oops, sorry. We don't need to rewrite that to just save space. The one that works is the floor of x equals -2. So -2 equals -3 times 2/3. So again, the floor plus the fractional value gives us that this case is x is equals to -4/3. So just adding all of these things up, the green portion is 7 5/7. And the black portion here, there's 2 solutions, it's just -2. So -2 gives us that the number we're actually looking for is just 5 5/7, or written in fractional form, in improper fraction form, is 40/7. So we are looking for p plus q, so that is 40 plus 7 equals 47. Okay. Hopefully this solution was helpful and educational. If it is, do hit the like button and subscribe. Again, thank you for watching.